Hi everyone, Brian here from Water Control Corporation. Today I want to talk to you about reverse osmosis. Reverse osmosis, or RO, is the most well-known example of what we call membrane filtration. In order to understand reverse osmosis, we need to first define the word osmosis itself. The dictionary definition of osmosis is the movement of a solvent through a semi-permeable membrane from an area of low concentration to an area of higher concentration. Wow, that's a mouthful. A membrane is really just a barrier. A permeable membrane is a barrier that things can pass through. So a semi-permeable membrane is a barrier that only some things can pass through. Now in the plumbing world, we use membranes, or really just big rolls of specialized fabric, that are designed to only allow liquid water to pass through them. To describe osmosis, imagine the following. So we take a fish tank and we stick a piece of this membrane down the middle, dividing the tank in half. On one side of the tank, we add fresh water. On the other side of the tank, we add salt water. And then we wait. After a period of time, some of the water from the fresh side will pass through that membrane, traveling over to the salty side. In fact, the water level on the salty side of the tank will actually be higher than the water on the fresh side. This is that process of a solvent, or water in this case, moving from an area of low concentration, the fresh side, to an area of high concentration, the salty side. The water level on the salty side will continue to rise until the head pressure and atmospheric pressure overcome the natural osmotic pressure that is being created. So reverse osmosis means we reverse this process using artificial pressure from a pump or a city supply. In other words, we pump the highly concentrated or salty side against the membrane. The artificial pressure being applied actually causes the water to move from the area of high concentration, the salty side, to the area of low concentration, the fresh side. When we do this in a real RO membrane, this generates two streams of water. A fresh or pure water stream, which we call our permeate, since it has literally permeated the membrane, and a salty or concentrated water stream, which we call our concentrate. The permeate is captured and used. The concentrate is usually sent down the drain unless there is some sort of a reuse system in place. Most residential systems create 3 or 4 gallons of concentrate for every 1 gallon of permeate generated. Commercial systems, on the other hand, are usually 1-to-1 permeate to concentrate due to the pumps involved. These two streams of water perform a process that we call cross-flow filtration. In a word, the filter is constantly being flushed, giving it a much longer lifespan than normal flow-through filters. Sometimes water produced with reverse osmosis is further purified using deionization media. In general, though, we can achieve about a 96 to 99% reduction in levels of dissolved solids using RO alone.